Hi, welcome to the series of videos on preparation for the quantitative reasoning section of our GMAT exam. As you know, the GMAT score of 800 is mainly scored for your quantitative quantitative reasoning and verbal reasoning. Quantitative reasoning is scored out of a scale of Q6 to a Q51, and today we will be looking at some problem solving questions for our quantitative reasoning part on the topic of combinations. Let's look at some sample questions now. So, the first question says, a diagonal of a polygon is a line connecting two vertices which is not an edge of the polygon. How many different diagonals can be drawn within a regular 8-sided polygon? Okay, so an 8-sided polygon will have 8 vertices also. And right in the question we have the definition of diagonal, that it is connecting any two vertices. Connecting any two vertices, so let us select 2 out of 8, that is given by 8C2. You are selecting 2 vertices out of the 8 vertices. Now, it is also given that which is not an edge of the polygon. We have 8 edges, correct, 8 sides. So, we have to subtract 8. We do not want to count the sides or the edges, for they are not the diagonals. Okay. So, 8C2 we remember from the formula of NCR will be n factorial by n minus r factorial into r factorial. 8C2 is nothing but 8 factorial divided by 6 factorial, 8 minus 2 is 6 and 2 factorial minus 8. This is the total number of diagonals. So, 6 factorial and 6 factorial will get cancelled. 8 factorial is nothing but 8 into 7 into 6 factorial divided by 6 factorial into 2 factorial. 6 factorial gets cancelled. You are left with 8 into 7 divided by 2 minus 8. It is 2 cancels out 8 4 times, 4 7s are 28, minus 8 is equals to 20. So, there are a total of 20 diagonals. So, our option B is the correct answer. Let us see what the next question is. A 3-digit positive integer consists of non-zero digits. If exactly 2 of the digits are the same, how many such integers are possible? Okay. So, what is the question saying? 3-digit positive integer consists of non-zero digits. So, non-zero digits, what are you left with? 1 to 9. You have 9 non-zero digits. If exactly 2 digits are the same, okay, it is a 3-digit integer, and 2 of the digits are same. Let us say those 2 are x. So, how can our 2 digits be same and the third digit is different? So, it is, let us say it is y. How many such integers are possible? Okay. So, let us see, it can be written as xxy or xyx or yxx. These are 3 different types where you can have 2 digits are similar and 1 is different. Now, what are they saying? How many digits are possible? Okay, so when you are taking this example of xxy, you can you need to select one digit out of the 9 digits, 1 to 9. Select one from them to be x, so that will be 9C1 into, you will select one from the remaining 8 digits to be y. So, this is how you can select x and y, 9C1 into 8C1. 9C1 is nothing but 9 and 8C1 is 8, and there are 3 different combinations of x and y that you can arrange it in. So, the total number will come out to be, this is to choose x and y we have this 𝗳𝗧1. Now, the total number of different total possible integers will be choosing x and y, that is 9 into 8 into 3, because there are 3 ways in which we can arrange them. So, that will come out to be 9 3s are 27, 27 into 8 is 7 8s are 56, 8 2s are 16, plus 2 plus 5 is 216. Answer is option C. Okay, this next question says, how many odd positive integers with distinct digits can be created using the digits 1, 2, 3, 4, 5 and 6? Okay, we are given 6 digits here and they are saying how many odd positive integers, with distinct digits. So, they are not repeating, the digits are not repeating, can be created using this. Okay. So, for a number to be odd, the units place should always be odd. That is the only requirement. So, we can have a 6-digit number where you have 6 digits 1, 2, 3, 4, 5, 6 and the units digit can only be 1, 3 or 5. So, there are 3 ways in which you can select your units digit out of these 3 odd digits that are given in this range, and after selecting your units digit, you will be left with 5 digits. From 1 to 6 there are totally 6 digits, but now you are left with 5 because you are filling one of these units digit with an odd digit. So, you are left with 5 options. So, this can be filled in 5 ways, this can be filled in 4 ways, and then this can be filled in 3 ways, this can be filled in 2 ways, this can be filled in 1 way. So, 6-digit, how many 6-digit numbers can be formed? It can be, it will be 5 into 4 into 3 into 2 into 1 into 3. We have to fill all of these digits, it's AND, so that is why we are multiplying the number of ways that each of these digits can be selected and filled. So, that comes out to be 10 and 12 120 into 3 360. Now, let us look at a 5-digit number. You can also make a 5-digit number. You do not necessarily have to make a 6-digit number. When you make 5-digit number, again the requirement is same. Here the units digit can be filled in 3 ways only, the 1, 3 or 5, just as we did before. And now again you are left with 5 because you have selected 1 out of the 6, you are left with 5 unique digits. This is because repetition is not allowed, they are called distinct digits. Repetition is not allowed, so that is why you have 5 options to fill this one with, you have 4 options to fill this one with, you have 3 options to fill this digit with, you have 2 options to fill this digit. So, the total comes out to be 5 into 4 into 3 into 2 into 3. This is again equal to 360. Now, let us look at a 4-digit number. One, 2, 3, 4. You will fill this place with 3, one of the 3 odd numbers. Now, then you are left with 5. So, you can fill this with 5, one of the 5 numbers that are left, 5, 4 and this can be filled in 3 ways. So, the total comes out to be 5 4s are 3 into 3. It comes out to be 180. 3-digit, now let us look at 3-digit numbers. When you have 3 digits to fill, you will first fill this with an odd number, that is 3 ways. Now, you are left with 5 ways you can fill this one and 4 ways you can fill this one. 5 into 4 into 3, that is equals to 60. Similarly, for a 2-digit number, you first fill this with 3, one of the 3 odd numbers, and you are left with 5. So, you fill this with 5, one of the 5 numbers, that is in 5 ways you can fill them. 5 into 3 is 15, and a 1-digit number, since you can fill it by one of the 3 odd numbers. So, 3 ways, total is 3. So, when you add all of these, you will get the total number of ways, and the sum comes out to be 3 plus 15, you get an 8 in the units digit. There is only one option with 8 in its units digit, so you can just select option D instead of calculating the total sum, or else calculating the sum also won't take much time. You will get 978 as the answer, that is option D. Let's look at more questions on this. In how many ways can team of 3 people be selected from a group of 4 boys and 6 girls such that at least one boy is selected? Okay, the question is telling us there are 4 boys and 6 girls, and we need a team of 3 people. Okay, so they are saying that at least one boy is selected. We need to check those options. So, we can either do that or a simpler way to deal with such problems is, you can at least one boy needs to be selected is equivalent to, when you can have the total number of ways minus no boys selected. So, the total we have is 10 people, 4 boys, 6 girls. So, we have 10 people. That will be, out of 10 you need to select how many? Only 3. So, you select 3 out of the 10 minus when no boys are selected, that means all girls. No boys selected is same as saying all girls are selected. All selected are girls, that is only girls are selected. So, out of the 6 girls you select 3. So, when you subtract the option where no boys are selected, that is all girls are selected, then you automatically remove it from the total number of ways and you will get at least one boy is selected. So, that 10C3 minus 6C3, 10C3 is nothing but 10 factor 10 into 9 into 8 divided by 1 into 2 into 3. This is another way you can calculate. Okay, so 2 3s are 6, it gets cancelled. So, you have 120 minus 5 4s are 20. So, you have 100. 100 is the number of ways in which at least one boy is selected. The option comes out as option C is your answer. Let's see what the next question is. As it says that the number of boys is twice the number of girls. So, if we assume that the number of girls is x, then the number of boys will be 2x. A team of 8 students is to be selected with 5 boys and 3 girls in the team. In how many ways can this be done if number of students in the class is 15? So, they are saying the total number of students is 15. That means x plus 2x is to be 15, which means that 3x is 15 and x comes out to be 5. So, when x is 5, so the number of girls will be 5 and the number of boys will be 2x, that is 2 into 5, it is 10. Okay. So, a team of 8 students is selected with 5 boys and 3 girls. So, if you are selecting 5 boys out of these 10 boys, how many ways can you do that? by 𝗳𝐶5. You're selecting 5 boys and you're selecting 3 girls. Out of these 5 girls, you want to select 3. So that becomes 𝗧𝗦𝗔𝗧 ways. And you have to do both of this. You have to select this. So if you solve this, 10, 9, 8, 7, 6 divided by 1, 2, 3, 4, 5 into 𝗧𝐶3 is 543 into 1, 2, 3. Okay. 3 2s is 6, 4 2s is 8, 5 2s is 10. So you have 4 9s are 36, 36 into 7 here, and 3 5 2s are, that is 10. 7 6 are 42, 7 3 is 21, 25, 2520. Answer comes out as option E. Option E is your answer here. I hope that is clear. We multiplied 𝗳𝐶5 into 𝗧𝐶3 because we calculated the number of girls as 5 and number of boys as 10. And choosing 5 boys out of the 10 in 𝗳𝐶5 ways and choosing 3 girls out of those 5 are 𝗧𝐶3 ways. Let's see what the next question is. How many different 4-digit numbers can be written using the digits 1 to 8 without repetition such that a number always contains the digit 2? So they are using what? Digits that are 1 to 8. So that means there are total of 8 digits, and you need to form 4 different 4-digit numbers without repetition. So you have to find 4-digit numbers. Then they are also saying that it will always contain the digit 2. Okay, so there are 4 places. The digit 2 can fill one of these 4 places in how many ways? In 𝗳𝐶1 ways to have the digit 2. Now once you are done with that, selecting which place to put 2 in, you are left with how many? You are left with 7. Because you took away 2 and there is no repetition, you are left with 7 digits from which you can choose. So once the 2 digit is fixed, let's say it's in the units place, you will have 7 ways to fill, and then you can fill this in 6 ways and you can fill this in 5 ways. So the total number of ways that you can have this number with 2 is selected in 𝗳𝐶1 ways. Where will it be? Then you can fill the remaining 3 digits in 7 into 6 into 5 ways. 7 4s are 28, 𝗳𝐶1 is nothing but 4, 6 5s are 30, 3 8s are 24, 3 2 6 7 8, 840 comes out as option D. Your answer is option D. Let's look at another question. How many 5-digit numbers can be formed using 567290 if no digits can be repeated? So you want a 5-digit number, okay, and you're given these digits 5, 6, 7, 2, 9 and 0. There are totally 6 different digits. So if you want a 5-digit number, you know that 0 can't come here in your 5th digits place, because then that will become a 4-digit number. So when 0 can't come here, so out of the 6 you are left with only 5 choices for your digit at the beginning of the 5-digit number. So you can fill this in 5 ways. Now when you look at how many ways you can fill this digit, it's now you can have 0 as well. You will have one less because you already selected 1 to fill this place. You will be left with 5 again because you are adding back 0 into the option pool. Now you can fill this in 4 ways, 4 different ways. You can fill this in 3 different ways. You can fill this in 2 different ways. So the total number 5-digit numbers, it will be 5 into 5 into 4 into 3 into 2. 25 into 4 is 100 into 6 is 600. Answer comes out to be option D. I hope that was clear. So what happens is, when you fill one of these digits, you are left with only, you might think that you are left with only 4 digits, but it is still 5, because now you have 0 also as a choice, which you did not have here. You cannot fill 0 here, but you can fill 0 here. That's why you are having 5 choices from which you can select. So, you will select that in 5 ways. Let's look at another question. In how many ways letters of the word acumen be arranged such that the vowels always appear together? Okay. So, in this word ACUMEN, what are your vowels? Your vowels are A, U and E, and you want them always to appear together. So, you are left with C, M and N. So, now you are left with, if you think of these 3 vowels, since they have to be together, let us consider them as one unit. So, this is 1, this is 1, and this is 1, this is 1. You have 4 different units or letters to arrange. So, 4 can be arranged in 4 factorial ways, 4 different units, 4 different considering this as one alphabet, you have 4 different, you can say that 4 different alphabets, you can arrange them in 4 factorial way, and within themselves these 3 alphabets can be arranged in how many ways? They within themselves they can be arranged in 3 factorial ways. So and you can do them both. So, that is why the total number of ways of arrangements is equals to 4 factorial into 3 factorial. It is option D, 4 factorial into 3 factorial. So, I hope it was clear. What we did was treat all these vowels as one unique alphabet, and within themselves they can be arranged in 3 factorial ways, because there are actually 3 different vowels, and but you are left with 4 different units to be arranged, that is going to be arranged in 4 factorial ways. So, those were some sample questions on our topic for today, that is combinations. I hope they were clear. Thank you for watching.